For the final video lesson of Unit 3, we're going to talk about using a line of best fit. Now, we will be using this in further lessons to learn more about relationships between various objects and various variables. So this is a really important lesson for mathematics. It's also used extensively in science for determining the results of different experiments, that kind of thing. So this is a life skill that will be really good to have. So what is a line of best fit? A line of best fit is a line that represents the relationship between variables okay. It minimizes the distance from points to the line to try and show kind of the true relationship hiding behind the variability of real-world data. Now, we know that real-world data is messier than that beautiful, clean relationship lines we get from using equations to determine linear relationships. So if we have an equation, we determine what the points are, and we plot them, and it's this lovely, simple way of creating a straight line. In real life, information is not so clear-cut. So when you're gathering data from real life, you tend to find that things can look a little bit messy, and they aren't going to have a perfect line because there's lots of variability. And the graph that I've chosen for you today, the scatter plot I've chosen for you today, is a perfect example of that. Here, we're looking at two different variables, diamonds, their size in carat, and the prices that they sold for. Now, we're missing a little bit of information here. We have a title. Okay, that's one thing we have. We have our labels. But do we have units? We have units here. Carats is units there. We don't have units here, so maybe we'll say that that is dollars. Whether it's Canadian or US, we don't know because the scatter plot label doesn't tell us, which is one reason this scatter plot would not be getting 100%. So I want to know what is the relationship. And by looking at the graph, I can determine a couple things. I can say that it looks linear. I can say that it is positive. My apologies there. Oh, we've got a little bit of lag going on. There we go. It's linear. It's positive. I'd say it's a strong relationship. Right? But what I can't do is I can't use this data for another reason. And that's what the line of best fit will do for us. So a line of best fit, remember I said it has to minimize the distance between the points. So I'm just going to tilt this down a little bit. Let me see if I can get this so that you can see it. I don't know if that's going to work. Okay. New plan. All right, so that you can see what I'm doing as well as see what's looking on the board. So I'm going to take my ruler and I'm going to try and find a line that represents this as best I can. I don't want all the numbers above it. I don't want all the numbers below it. I need a line that splits the points. I want the same number of points above, the same number of points below, and try and make sure there's not a huge variance between them. So let me draw a couple lines and we'll determine which one is the best. All right. So pick green. I'm going to draw a line. that. I'm going to blue. Oh, I don't have a solid surface here. My line got a little bit wiggly. All right. And let's pick one more color and like that. All right. Now, which line is actually the best line? The pink line, the blue line, or the green line? So let's look. The blue line goes through a couple of these points, but then almost all the points are below the blue line. So the blue line's not a good line. So we're going to take the blue line. Oopsies. I'm going to have to redo the pink line. Take the blue line out of there. What about the green line? The green line looks like it's doing really well down at the bottom of the graph, but then it misses all the points on the top. So the green line is also not a good line. Line of best fit. So let's take a look again at that pink line. Let me draw that back in for you. Okay, so that's pretty close to the same line. Now when you look at it, there's points below, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's points above, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That point there, the very top point is on the line, but a little above it, so we'll go 11. So I've got 13 and 11, which pretty good. If you look at the spread up and down on that line, they're clustered pretty tightly to the line. So I would say that's not a bad line of best fit. You can get computers to do this, and the computers will put the trend lines in exactly perfectly, minimizing the error between all the points, and that's obviously the most accurate way of doing it, but we can learn a lot still by doing it by hand. So now that I have the line here, what is that for? It's not just to make it look even more obvious that it's linear, positive, and strong, because that's pretty obvious on this graph anyway. What is that line of best fit going to be for? And it's going to be for these last two vocabulary words, interpolation and extrapolation. So an example of interpolation is going to be, I could ask you a question saying, how much would a diamond cost that was 0.325 carats? Okay. How much would that diamond cost? So if we say 0.325 is here, so 0.325 is here, I'm going to go straight up to my line right there. From my line, I'm going to go all the way across to there. And that looks like it's going up by 100s. That looks like about $990. So what I've got here is, I write out my question, how much would a diamond 0.325 carats cost? Wait for that to catch up with us. Okay. And I've just found that answer is approximately $990. That is an example of interpolation. Interpolation, inter means between. Interpolation is just using existing data to find a number within the existing data. So you can see that I am looking inside my data. I don't have any data that's lower than, I don't have any data that looks like it's lower than 0.125, and I don't have any data that's higher than 0.035. So what I'm looking for is in between the data. So that's interpolation. Extrapolation is outside the data. So if I wanted to know extrapolation, how much would a diamond 0.375 carats cost? So let's go here. 0.375 is right here, 0.375. It's probably actually a little bit further in. But in this case, I'm looking right at that point. And so that's going to be, my cost here, we'll say $11.50. So I could say $1,150 approximately. And that's called extrapolation. And extrapolation means outside of your data. That's what extra actually means. If you're extraordinary, that breaks down to extraordinary, which means out of the ordinary. So whatever the classification of ordinary is, someone who's extraordinary is outside of that classification. And when I'm extrapolating, I'm extending my data to find a value outside of what I had measured or what I had observed or what I had recorded. And so that's what a line of best fit can be used for. That's what we will be using it for in class. And that is how you create one.